Hi, I'm Ahmed Dawood, and in this session, we will try to analyze or learn linear regression by Scikit-Learn library. Till now, we have done theoretically what is linear regression actually, and how it can be trained. Okay, we have learned two methods. First one is gradient descent, and second one was a normal equation. And I have told you in the last session of normal equation that linear regression also follow the technique of normal equation with a little bit tweakness. Okay, so this is a documentation of linear regression provided by the Scikit-Learn. So here you can see ordinary least squares linear regression. Linear regression fits a linear model with coefficients. Coefficients, I told you that a coefficient, if there is only one independent variable, then there will be only one coefficient. Like in our case, we have m. M was the coefficient and c was the intercept. So to minimize the residual sum of squares between the observed targets in the dataset and the targets predicted by the linear approximation. It's the same like that to minimize the sum of squared error you can say here. They have used the residual. The residual also can be used for the error or how much the difference between the actual value and the predicted value. Okay, so this linear regression also use that approach. If you are interested in to see the code of linear regression, you can refer that yeah, you can refer from here, and here you will see they have written a Python code. You can see that code if someone of you are interested in to see the code of how they have implemented linear regression. Okay, now there are some of the parameters and some of the attributes. I will not go in too much detail of the parameters. We will do in the Jupyter notebook how we can use that. But if you are interested, you can go that in. You can refer this documentation and you can learn or see from here. There are a lot of detail here. Okay, so here just uh, you can say a view or overview I want to give here. Like fit intercept, it's a parameter which is by default is true, but if you want to make it false, you can do that. Okay, what actually it means? It means if you have it means if you have so if you have here let's say y is equal mx plus c equation, and if you are interested into just you are interested that your model should be at the origin. Okay, it should not have intercept in it. You can make here fit intercept is equal to false. Okay, I will tell you what actually I am saying here. Let's say your equation is simply y is equal mx plus c. Okay, normally you have the equation like that, and it when you are have this data set and you are trying to fit a model, it will be like that. Okay, this from here to here, this distance is uh, actually the intercept c, this one. Okay, so if you want a model such that it only have a coefficient here. Okay, it don't have any intercept, like it don't have this part, then you can make here fit intercept is equal to false. What is advantage of that? Advantage is that if you already know that uh, your data is centered data, your data is like this one. Okay, is already centered, then you don't need to start from here, or you don't need to have some sort of intercept. You can simply if I will make here, yeah, you can simply without the intercept, you can have a model. Okay, which already will be on the uh, origin of the data. Okay, or you can say which will be already on the origin. Okay, so plus c if and by default fit intercept is equal to true already. So by default you are using this equation, but if you will make fit intercept equal to false, equal to false. If you will make this one, then you will have such a model which has this equation y is equal to mx, and this equation will remain at the origin. Okay, in this way. Okay, it will be on origin instead of, if you have intercept, then it will have some distance from the origin. Okay, so come back here. So fit intercept, if you are sure that your data is at origin, or here they have also mentioned, if data is expected to be centered, then you can use that. Fit intercept is equal to false. Now, second one is normalize. If you can recall in the session of EDA, exploratory data analysis, I told you that scaling can be used to make all the variables on the same scale. Okay, or you can say to make the variables data to the centered data. Okay, if you can recall standard scalar we have used, and we have learned a lot of in the last sessions, when we are subtracting the mean from the each value and divided by some standard deviation. Okay, we are actually making the data on the same scale, and there are some other purposes also. But here, if you want to do that normalization, you can also do that. This normalization will actually do in this way. It will shift your data to the origin if your data is not at origin. So this parameter is ignored when fit intercept is set to false. If intercept is set to false, it means that you are not using you are not using the intercept already, and why are you not using if fit intercept is equal to false, fit intercept, or why are you not using intercept in your model? The reason was that if you are sure that your data is centered, if your data is centered here. Okay, so this parameter is they are saying that if this parameter is ignored by default when your intercept is equal to false. Okay, if you are already sure your data is centered and you have make fit intercept is equal to false, then no need to do normalization. Your data is already centered. But if you have made this fit intercept equal to true, this will show that your data is not centered. So that's why you are adding some intercept. If you are adding some intercept, so there is need to do some normalization. Okay, then the regressor X will be normalized before regression part, before the training part, by subtracting the mean. They are subtracting the mean and dividing by L to norm. Okay, we will see in the later sessions what is L to norm. So if you wish to standardize, please use, and they are also saying if you don't want to use this normalized parameter and you want to do scaling by yourself before the feeding the data to the model, you can use the standard scaler. Okay. Now I hope you got an idea. This normal, for simplicity, you can say normalize parameter helps you to normalize the data. Okay, to scale the data to the origin. Okay. Now copy X parameter is also just to if you are interested in the copy of the data set that you have, or you are directly using your data. Okay, so here they have mentioned. And jobs is for multi processing. If you want to train your model and you want such that your uh, uh, training will be complete in short time, and you want parallel processing. So in that case, and jobs usually use, but in our case, it's not important. Positive parameter is set to true. Forces the coefficient. It makes coefficient to be forced and try to make the coefficients to be positive. Okay, uh, so that's why you can use if it depends on the situation where we need such a coefficient to be positive, but generally we don't have to need that. And here you can say the default parameters they have set for the generalized cases, general cases. Okay, if you are using your model in some specific case, then you have to explore each parameter one by one. But generally they have the default parameters, default values are enough for us to use that. Okay, so this option is only supported for dense arrays. Okay, dense array and sparse array. If I will, okay, so sparse array, such type of arrays which has a lot of values empty in that array, or a lot of values are zero. Dense values, dense arrays usually that have a lot of values. All the array is full of entries. Okay, sparsity and density you can see that, but for this session it is not important. For this session you can see you can see and by yourself from this documentation what are these parameters, but hopefully for you it's enough to use this linear regression. uh, to go in the detail, you can do practice by yourself or uh, by one using these parameters. Okay, so this fit intercept parameter is really interesting. It makes your model's equation or equation of line y is equal mx. Okay, and if you will make fit interceptor is equal to true, which is by default, then your equation will be remain same that we have learned theoretically. Okay, now there are some of the attributes if you want after training of your model, you can use these attributes, and some of rank singular, these are some mathematical uh, attributes or mathematical you can say, you can if you have you already know about the rank and singular values, and you are using your linear regression for the case where you have need to do that, to use this rank and singular values, then you can use that. But for now it's not to go in not important to go in the detail of that. Coefficient is the same, like here I have mentioned, these are the coefficient. This m is coefficient and this is intercept. Okay, if you will print you will use attribute dot coefficient after training of your model, it will give you the value. In the same way, if you will use the attribute intercept, it will give you the value. And here the n features and feature name, if you want to see what are your features, uh, like in our case there are it is in input features. Okay, that are we are giving our to our model. Like here we are using here just one feature, area and price. Okay, there is one input and one output. Okay, this is one independent variable and there is one dependent. So these features in just give you independent variables, names of the input independent variables. Okay, this will give you the number of how many number of features you are using as an independent variable, and this will give you how many what are the names of that independent variables that you are using. Okay, so come back to the our today's session is will be on uh, how we can use linear regression from sklearn. So first of all, as usual, I will import pandas as pd. Here I am importing sklearn.linear model. From this linear model I am importing linear regression, and here I have imported seaborn. I have a small data here. I am just creating a data frame, so that's why I have made here two lists. One list is area, price, and from by using the this dictionary, I have uh, I have made here a data frame, area, price. Okay, so I have plotted a scatter plot. On the x-axis there is area, on the y-axis there is a price in lakhs, like 20 area, or you can say house of 2600 square feet is of 5.5 lakh. Okay, in this way this data each observation explained. You have seen this is the points, and a lot of times I have shown you in the last sessions this scatter plot. Okay, there are just 5 samples in it. Now, this model, I am creating an instance of linear regression. This linear regression we have imported. This linear regression class. Here I am creating an instance of that class, which will be our model, linear regression. Here if you want such a model, let's say if I will make here by using a comment. Okay, so if okay, I will make it in this way. If you want such a model that have an equation y is equal mx, okay, instead of y is equal mx plus c. So you can make here fit underscore intercept is equal to false. Okay, this will give you such a model that has that will have sorry, I will make here hash that will have equation y is equal mx. Okay, okay, but instead of that we are using here the equation, the model which are using default parameters, and in the default parameters, we have equation like that, mx plus c, where we also have this intercept c. Okay, now here the training part. In the training part, linear model, this linear model we are using here, which has this equation. So dot fit, I told you last time that just a fit function do all the stuff that we have done here. Okay, as I told you that sklearn used only this normal equation method. If I will zoom out, okay, this normal equation method sklearn used, it don't used in case of linear regression sklearn use this method normal equation. It don't use the method of gradient descent. I told you because of the nature of the function, error function that we have here. Like here we have an error function SSE. That's why it can use this direct method. So here we have done a lot of maths. We have calculated the gradients, make it equal to 0, then calculate the equations, then calculate the parameters. But here, just use the fit model, fit function, and it will do all the stuff for you. Okay, I will run that here. Yeah, I have run here fit function, and here I will pass the input, which is this one, my independent variables, which has just one variable area, and dependent variable which is price. Okay, now the training is end. Okay, so I have these comments here, I have used to just for you give you an idea that how simple is to use the code. But when you have learned all this stuff theoretically, then you can more you can get an idea about these parameters, what is this fit intercept and stuff like that. Okay, if you have not done that, the theoretical part, then maybe in the next sessions when we were doing neural networks and some other logistic regression, maybe you will get confused. Okay, so for the coding part, to import the library and use that, it's really easy. Okay, now here we have trained our model. Now if you are interested what is the coefficient we have uh, got here, or you can say the coefficient, optimal coefficient, which the coefficient at the minimum SSE point. Okay, so here 0.135, and theoretically when we are doing, we also have calculated this one 1358. Okay, and when we will run intercept 1.806, and here, okay, here the linear regression, sklearn linear regression also giving the same coefficient and intercept that we have calculated by ourselves theoretically. Okay, so here I have told you this parameter, this attribute just give you a number of features that are using you as an input. Okay, or independent features. Here just you are using one feature, so that's why it has printed one. If you are interested in printing the name of that feature, you can use this attribute feature underscore names underscore a. Okay, now here I am just passing these values, this coefficient, this intercept, in variables m and c, so that we can draw here a red model. Okay, so here m and c, m is coefficient, c, so that you can compare, or you can sync your practical part with your theoretical part. In theoretical part you have equation like y is equal to mx plus c, so that's why here I am using. So this is scatter plot, the scatter plot that we have used above also here, and here I am using seaborn line plot, and here I am giving the color red to give you some distinction between, and give you an idea that this red is model and blue points that we have in our training data set. Here on the axis like is our input data, like on the axis will be area, which is our original, and here I am using this equation. This you can consider as a y cap. Y cap is equal mx plus c. Okay, and this give you a line. Okay, here you can see. Now you have trained your model. You have find out your m and c. You have seen here intercept coefficient m and c. You have already know what are your m and c. And now, if you are interested into doing some prediction or testing your model, you can use this function LR model that we have linear model dot predict function. Okay, dot predict function here I am passing again the same data that we have used during training process, because here we have just 5 points, so that's why don't use the technique of train test supplement. Okay, so here I am passing this data, these 5 points, and here I got these 5 points. Okay, five predictions. Now we will do a comparison. Here you can see this data set we have originally. This is area, this is price, and these are the predicted price by our model. Okay, so this is 5.3366, but original price is 5.5. This is 5.8, but original is 5.65. As I told you that our model is trying to reduce the error, reduce the difference between the predicted and actual values. But always it is not ideal case that there will be zero difference. Okay, like here in the last, you have seen that the actual price is 7.25, but the predicted price is 7.24 approximately. Okay, so we want such a model that have very less error. Okay, very less error, um, very less difference between the predicted and actual prices. Okay, so later on we will see some regression metrics. How can we evaluate that our model is good or bad? Like here we have this model. How we can come to know that this model is good or bad? And if we have to do comparison with this model with some other models, then we should have some metrics or some metric that can give us a value that this model is good or bad. Okay, so that. So I hope you learned a lot, and it's a very simple session. I hope you have enjoyed that. And for now, thank you.